In February 1997, 3 physicists signed a bet. 2 of them used a pen. The third pressed his thumb into the ink. That was Stephen Hawking. By then, the thumbprint was his signature. He was betting that things can be destroyed completely, not hidden, not scrambled, erased. After 20 years of his own work said so, 7 years later he walked it back in front of television cameras. But that is not the strange part. The man who won that bet later admitted something. He could not follow the argument that won it for him. He took the prize anyway. This is one question, asked 4 times. Can anything actually be destroyed? Hawking answered with equations, and then reversed himself. A Roman poet answered 2,000 years earlier, and never moved. So did the Bhagavad Gita, about something else entirely. And one tradition refuses the question outright. It says there is nothing permanent underneath for destruction to happen to. None of these old texts were doing physics. They were not predicting anything. They were standing at the same wall from the other side. Keep that in mind. Start in 1974 with a calculation nobody expected. Picture the edge of a black hole. Not the hole, the boundary around it. Past that line, light can no longer escape to the outside universe. Hawking worked out what empty space does at that boundary. And empty space, in quantum theory, is not empty. It flickers, constantly. The usual picture is a pair of particles appearing at the edge. One falls in, the other escapes. That picture is a shortcut, not the calculation. The real result comes from quantum fields in curved spacetime, but the outcome is the same either way. The black hole radiates. It loses energy. It shrinks. On paper, black holes evaporate. That result made him famous. The calculation is widely trusted. It has also never been observed. For any real black hole, the effect is far too faint to see. Then Hawking noticed what was sitting underneath his own result. Try it with an encyclopedia. Burn volume A. Then burn volume B. The flames look identical. The ashes look identical. But they are not. With enough cleverness, and technology nobody has, you could read the difference. You could say which volume burned. That is not a poetic idea. It is a requirement. For an isolated quantum system, the information in its state survives, scrambled past any practical hope of reading, not erased. Now throw volume A into a black hole instead. The black hole radiates. It shrinks. It disappears. And Hawking's calculation said, the radiatio carries no recoverable trace of what fell in. Nothing to decipher, no hidden copy, no ashes to read. This is the information paradox. Either black holes erase something that quantum theory says cannot be erased, or the calculation is wrong. Hawking spent 20 years insisting it was quantum theory that had to give. On the 6th of February, 1997, in a room in Pasadena, he put that in writing. The document is 1 page, Hawking and Kip Thorne on one side. On the other, the physicist who tells the encyclopedia story, John Preskill. The bet states Preskill's position in technical language. The final state would always be a pure quantum state. In plainer words, whatever fell in, the information survives. Hawking and Thorne bet against him. The stakes were written into the page. The loser owes the winner an encyclopedia. The wording is exact, an encyclopedia from which information can be retrieved at will. Physicists making a joke about the thing they were arguing over. At the bottom, 2 ink signatures and a thumbprint. Hawking had lived with motor neuron disease for over 30 years. The thumbprint was how he signed. That page sits behind glass in a London museum now. Here is what makes that page worth this much attention. Hawking was defending a position almost nobody has ever wanted to hold. Not just in physics, in any tradition, that a thing can go completely out of existence, leaving no trace of any kind. For 2,500 years, people who thought hard about this kept refusing to say yes. They refused for different reasons, and they were not comforting reasons. Start in Rome, in the 1st century before the Common Era. Lucretius wrote one long poem, On the Nature of Things, 6 books, in Latin. He was an Epicurean. The world was atoms and empty space. No gods arranging anything, no plan. Everything in that poem rests on 2 claims. Nothing comes from nothing, and nothing goes back to nothing. The first one is easy to accept. The second is the one he had to fight for. And he did not simply assert it, he gave an argument. Suppose a thing could vanish completely, not break, not decay, vanish. Then destroying it would take no force at all. There would be nothing there to resist. Anything could go at any moment, for no reason. Nothing would need to be broken first. But that is not the world we live in. Things resist. Stone resists. Bone resists. Destruction takes effort. Which means, he concluded, there is something in things that does not get destroyed. The effort goes into rearranging it, never into deleting it. Here is William Ellery Leonard's 1916 translation. Nothing returns to naught, but all return at their collapse to primal forms of stuff. The form dissolves, the atoms do not. His physics is wrong in many important respects. He had no idea what an atom actually is. But look at the shape of the reasoning. He is not appealing to a god or to comfort. He is arguing from something you can check yourself. Things are hard to destroy. The Bhagavad Gita reaches a similar conclusion about something else entirely. And this is where comparisons like this usually break, so be careful here. Physics is talking about information. The Gita is talking about the ATMAN, the self. A physicist arguing that information is preserved is not arguing that you survive death. Nothing in this video claims otherwise. What they share is the shape of the question. Is there a layer that endures when the visible thing stops existing? Both answer yes, about different things. Chapter 2 of the Gita is a conversation on a battlefield. Arjuna has put his weapons down. The army facing him contains his own family. He cannot make himself fight. Krishna does not answer with strategy. He answers with a claim about what can be destroyed. Weapons do not cut it. Fire does not burn it. Water does not wet it. Wind does not dry it. 4 ways of destroying a thing. The text names them and rules them all out. Earlier in the same chapter is the sharper line. Of the unreal, there is no coming into being. Of the real, there is no ceasing to be. That sounds like a conservation law. It is not one. It is a metaphysical claim, and it makes no prediction that anyone can test. Hold on to that. Then there is the tradition that refuses the whole question, and it deserves a hearing because it may be right. Early Buddhism rejects a permanent, unchanging self or essence. Anicca, impermanence. It is not saying that things change while something quiet endures beneath them. It is saying that if you go looking for the enduring thing, you will not find one. Only conditioned processes, all the way down. That collides directly with the Gita's Atman. The 2 traditions have argued about it for 2,000 years. So do not picture ancient wisdom agreeing with itself. It does not. And the resemblance to physics ends quickly here, as it should. Buddhism says the object has no permanent essence. Physics asks whether the information describing it can be recovered. Those are not the same question. But they agree on one thing. The volume you burned is not coming back. So look at what happened across 25 centuries. Lucretius said nothing is destroyed and argued it from resistance. The Gita said nothing, real ceases, and meant the self. Early Buddhism said the question is malformed because nothing permanent is there in the first place. 3 refusals, 3 different reasons. And here is the thing about all 3. None of them has moved as a claim since the day it was written down. Not because anyone confirmed them, because no experiment can reach them. The 4th answer is the only one that ever changed. It has reversed twice, and it is still moving. On the 21st of July, 2004, Hawking asked to be added to a conference schedule in Dublin. Word traveled fast. The lecture drew reporters and television crews from around 50 countries. Thorne and Preskill were both in the city. Hawking asked them onto the stage with him. Then he told the room he had been wrong. His new argument was that black hole horizons are not as sharp as he had assumed. That information leaks out after all. He said it was good to solve a problem that had troubled him for nearly 30 years, and that the answer was less exciting than the alternative he had suggested. Some of the physicists in that room still held his old position. They were not pleased. He had not only changed his own mind, he had walked off a side of the argument that other people were still standing on. Then he settled the bet. He handed Preskill the 8th edition of Total Baseball, the ultimate baseball encyclopedia, 2,688 pages. Preskill lifted it over his head. He was asked later why he had wanted a printed book rather than a disc. His answer: print is heavy, like a black hole, and it takes much longer to get the information out. That is where the story usually stops. Hawking was wrong. Hawking admitted it. Everyone goes home. 3 things are missing from that version. The first, Kip Thorne signed the same page. He was standing on the same stage. He wanted to read the paper before deciding. He never did concede. The second, Preskill won, and then wrote something strange. He said he did not understand Hawking's new argument well enough to summarize it. He took the encyclopedia because refusing would have made no sense, and he was not sure he agreed with Hawking's reason for conceding. Read that again. The man who won could not follow the argument that handed him the win. The third thing missing is the largest. Conceding a bet is not the same as solving a problem. In 2012, a new difficulty appeared. If information really does escape, something else has to break. One proposal is that the horizon is replaced by an intensely energetic region. Physicists call it the firewall. It is still unresolved. In 2015, in Stockholm, Hawking proposed another way to account for the information. 11 years after conceding, he was still working on the thing he had conceded. So here is the honest position. In 2026, since 2019, there has been real progress. In simplified models, the mathematics now behaves as if the information escapes. What nobody has is an account of how it gets out of a real black hole. The bet was settled. The question was not. Which leaves the strangest part of the whole story. The claim built out of mathematics has been reversed, doubted, and reopened. The 3 older ones have not moved at all. That is not a point in their favor. Stability is not evidence. It is what happens to a claim no experiment can reach. Physics can be wrong in a way that shows it made a claim precise enough to lose a bet on. One thing you can check without any equipment. Look at any object near you. Nothing in it is original. Every atom was formed in some earlier cosmic process. It has been rearranged many times since. The object is a temporary arrangement. That is all it is. Now hold both thoughts at once. The arrangement will not last, and the matter composing it will be transformed and redistributed, not annihilated. That is the entire disagreement, sitting in one object. Lucretius emphasized the second. The Buddhists emphasized the first. Neither of them was making it up. In February 1997, 3 men signed a page in Pasadena, 2 signatures and a thumbprint. They were betting on whether a black hole can erase information completely. 7 years later, one of them changed his mind, one of them never did, and the one who won could not follow the argument. The page is behind glass in London. The information written on it has not been lost, which is, in a small and almost absurd way, the thing they were arguing about. Ancient wisdom, quantum mystery, direct knowing. This is quantum gnosis.